Author is a 3D print designer who has spent the last 10 years working as a 3D specialist and industrial designer and focuses on 3D design workflows. So today he hopes to be giving an outsider's perspective for O&P.
Fantastic. How are we all doing? Glad we could be here. Hopefully we get a few more trickling in. So my name is Arthur Hobden. I'm a digital design specialist and founder at the O&P Digital Designer Academy, and I'm also a business development manager for Taika 3D, which is a design automation company in software for custom insoles. I am from outside the industry, and I've spent the last 10 years touring all these different industries, implementing 3D scanning and 3D printing hardware, software, and workflows. I've seen the inside of factories that have blown my mind. I've been inside of a Toyota manufacturing plant. I've been inside a John Deere facility for QC. I've been inside a factory for how hot tubs were made. I've been touring around and finding new and unique ways to apply 3D scanning and 3D printing across a broad range of applications using a wide variety of teams and specializations. The two big hardwares of note that I've been part of it as a sales pipeline is Stratasys machines, so the high-end Stratasys 3D printing lineup for PolyJet, FDM or otherwise, as well as the Creaform 3D scanners, which are a very expensive scanning unit that can get down to 10 microns and is often used in QC for automotive and injection molding and what have you. These pieces of hardware have given me a great insider's view onto how these are being leveraged across a wide variety of industries. The reason why I do this is, as a designer, a product designer, I love learning about how things are made. I have a true passion for leveraging creative outputs in manufacturing and helping artists translate that into machining outputs. I've been on some amazing projects, including on the set of Star Trek Discovery, as well as Del Toro films. I've been refitting old sailboats in a marine yard. I've done woodworking with a friend of mine to build guitars and so many more. I've really enjoyed being a part of the digital workflow and being a creative output for creators in manufacturing. So O&P has become a bigger and bigger part of that journey. The demand for workflows in how to leverage 3D software and 3D design has really taken off in the last few years. And I actually made the transition away from my full-time job in broader manufacturing to focus on inroads for O&P because of the design requirements and the needs for digital design within O&P products right now and 3D printing. 3D printing as a medium is my favorite medium. Out of all the industries I've chosen and worked on, 3D printing is truly one of those open-ended platforms for creativity. There's impossible geometries that you can do with 3D printing that you can't get out of sheet metal, plastic and molding, injection molding, or otherwise. You can have really creative solutions for assemblies where you're taking an automotive part that took 50 parts in an hour to assemble. You can get it down to 3 and assemble it in 3 minutes. You can take interesting materials and one-shot a print that has both the rubber and the axle and the hard plastic all within one part as it comes out of the printer. And this rapid integration of innovation allows designers like me to have turnaround times of days rather than what used to be weeks. You would be engaging a Chinese factory looking to get samples and prototypes made, which would be shipped back, and you would revise and go through a design pipeline that would take months and months and months to facilitate, and was really, again, a stifling friction point in innovation. So this is a medium I'm really passionate about as a creative person, and I love sharing that potential with others. As I got more into 3D printing, I grew frustrated with the O&P market and what the industry was doing wrong, in my opinion. Based on my experience, the software providers in O&P did not reveal how they were doing things. As I was getting more deeper into the webinars of certain O&P software providers, they weren't showing anything other than an ecosystemic solution and not the tool set themselves for innovators in 3D printing like myself to be able to leverage and learn from. The software in O&P, specific software that was being offered, was 10 times the cost of what other softwares in 3D printing offer, and 10 times the cost of what I was used to paying as a designer myself. And the softwares of that price point had narrow outcomes, which really stifles the innovation of the 3D printed medium itself, which is really the whole point of the medium, in my opinion. to top it all off, what really got me was the proprietary hardware that some of these ecosystems would include, which would prevent you from, for example, exporting out a 3D scan from an ecosystem into another pipeline that you might want to use to help create or produce something of your own design rather than the outcomes of an O&P software provider. So what these friction points were doing was that it was creating an atmosphere where clinicians didn't know what they were buying into because the how was not there or available. And they didn't understand how these things were being made. Even though clinicians fundamentally are in the business of making things, you make products. Outsourced manufacturing and lead times were controlled, and the pricing in the beginning initially was something it was hard to bill for. Although this is getting better, the L code reimbursements are available and are definitely a part of the pricing model for software solutions today. And the financial high bar for these clinics to get into going digital for 3D printing often came down to software that cost $10,000 to $20,000 a year in subscriptions, and advocated for printer technology that was close to $500,000 to purchase up front in order to, follow the standards set forth by these software providers. So clinicians looking to get into 3D printing had novel ideas. Obviously, I met them every day. I would work with them online, and they couldn't explore it using any of these softwares and often got frustrated. Hardware that was made to prevent you from using it independently, again, it was something that was often a part of this problem, and many clinicians as a result have been pushing the idea that digital design is the obstacle between them and integrating 3D printing into their practice. And to me as a designer, I feel very strongly that this is very, very completely backwards and potentially even dangerous, which I can go into as to why I would feel that way based on my experience. So I'm here to offer you guys an outsider's view of what 3D printing is and what the market is and how O&P can and should leverage it. Because there's a lot of mature industries out there that have been leveraging 3D printing for a long time, and there are established languages in these communities for softwares, file types, scanning outputs, and workflows that legitimately costs 90% less than the industry-specific O&P softwares right now today. These industries outside of O&P are totally free to innovate and create incredible solutions without any limitations on their lateral movement on innovation or ideas. And the vendor network in this community of 3D printing is so strong that these industries know how to leverage them. You don't need to own these giant 3D printers in order to get into the game. And that piece of the puzzle is something that is not talked about enough in O&P. You can cut out the middleman and go direct to manufacture, provided you take on the risk and assume the risk of the design side of a medical product. So if anything, the one thing you guys should really take away from this presentation is design is the most important thing. It is the crown jewel that you should be seizing with both hands to keep for yourself. This is not something you should subscribe to. This is not something you should give away. You don't go to school to be a photographer to learn about which camera is the best one to get or what 2D printer you print your photos on. Those are besides the point. It's the eye behind the lens that makes you worthwhile as the artist or the artisan or the craftsman behind the trade you work in. So I want to introduce to you guys a paradigm in digital design tools called the digital craftsman. Creating a new mindset. This is going to give you a roadmap for being able to get into 3D printing today and to make the right decisions in software and hardware that's going to get you 80 to 90% less financial burden per year than traditional O&P solutions. And best part is you don't even need to own your own 3D printer to do this, and I'm going to show you how to do that. This is going to lower a barrier to entry today that's going to give you an absolute beeline solution to get into it for less than $500 a year in software costs. And that's essentially all you need to start up today. So I hope you're excited. This is something I'm really passionate about and I teach prevalently throughout some of the clinics I work with. Let's dive in and talk about design, because the 3D printing process talks about scan, design, and print, the three main stages of the digital design workflow today. Scanning, everyone has one in their pocket today. As we all know, the iPhone scanning is good enough today to get into the game easily and effectively and more accurately every month. There are several tiers of scanners ranging from free to all the way up to over $100,000 in metrology, and today you can get started for free. That's the best part. So scanning is solved. 3D printing on the other side of the spectrum as well, there are various price points, cheap printers, small printers, large printers. There's lots of materials, there's lots of processes. There's additive and subtractive manufacturing, which is milling. Those actually are a very complementary form of medium that is only just now being discovered. And there's a printer for every price point, right? So the middle step, the intermediary step of design, is where people like me would process a scan. They'll modify the anatomy, they'll create the trim lines, adjust and correct the anatomy, create a 3D printed product, and then generate the G-code to output for a 3D printer. So the interesting thing about these three steps is only one of them can leverage poor scans and good printers, and that is the design side. I don't care how good your scanner is, if you have a really bad printer, you're dead in the water. Similarly, if you have an amazing printer with full color, you're still dead in the water if your scanner or design is really poor. Good design, however, can leverage and offset poor scans, and it can also accommodate cheap printers and cheap materials, giving you the ability to get into the game with cheap scanners and printer solutions while still being able to provide definitive end-use products within just learning the design process and assuming that risk as a designer. So when you're a designer, you want to work with a tool set that works for you, and to choose a tool set is to choose a software. There's two main types of softwares you're going to know about. There's process-specific software, and then there's industry-specific software. Process software does not live in any one industry and has a large tool set and a large base of people who are using it. So a large customer base, what that means for you is that it's affordable and there's a community of support on YouTube or otherwise. So project management software, for example, invoicing software, or project management, especially every industry can use project management. Therefore, you can find solutions in that vein for as little as $5 to $10 a month, which is really, and lots of stuff on YouTube to figure out how to use it. Contrast that with industry-specific software. This is now software that's only applicable to one industry and solves a very niche problem within a small tool set. That small base of customers equals a very high price point and no peer support. So you're not going to find a peer network to leverage. You're not going to find things on YouTube. You're going to have to buy into a very expensive software and then pay a yearly maintenance fee to be able to access their team on support issues in order to get the outcomes, the narrow outcomes that this software provides. So as an example, anything today in O&P software, if you've got O&P project management software or O&P design software, because the industry is so small, the price point for these softwares is about 10 times higher. And that's fundamentally the economics behind why we can choose which software route to go. We can find process-specific software used in a variety of industries to drastically lower the costs and the barriers to get into digital workflows today. So O&P specific software, there's still definitely a place in what I'm talking about today, but you need to know where these companies serve and take from your business. Would you have bought the Vorum's Spectra scanner if you knew it wouldn't let you export models into your own software? If I'm harping on that a lot, it's because that's the part that really gets me sometimes. If you want to start a clinic with an iPhone scanner and a $200 desktop printer, you can do that. And I've helped clinics do this several times with process-specific CAD software. So a great example of this, one of the best success stories I have, NY Rehab Prosthetics out of New York, run with Mike Nadata. They have pioneered a brand new socket that they're using in their clinic. To date, they've put out 300 AK and BK definitive TPU FDM sockets using desktop Sidewinder printers. This is a $300 printer with a base stock print head with standard Shore 90 TPU filaments that are not proprietary. They've been around for a long time and they're nice and easy to access and get a hold of. They were able to learn from the academy that I'm offering for design to leverage two basic softwares found in other industries to be able to create their own designs. They were able to learn how to 3D scan, how to process those scans, and then turn around and leverage 3D printing markets and online vendors to print for them. They were then able to learn how to slice their own software and create their own prints themselves. And the best part about this outcome is that they were able to run over these parts with their SUV on camera, post it online, and to this day, those parts are still in use and on patients today. And so with a $500 piece of software and a $200 printer and stock materials, they are able to get to the end result right out of the gate with no strings attached, with full lateral design freedom to be able to explore things like vacuum seals or vacuum suspension, working with latticing on the outside, learning those design features, those rich design features and tools that these agnostic softwares can give you to explore and to find your product that fits for you and your practice and what you want to do. Giving you that lateral freedom is the whole point of what process-specific software can give you. Dynalim Technologies is another great example. These are people out of Nigeria who have a lab that's doing the exact same thing, a sidewinder printer, printing devices for kids with limb loss or limb difference. It's very hard to get a hold of a Sash foot online if you're in Nigeria from the US. So being able to create and learn how to design, learn how to print and source yourself to provide end products was something that they were able to do within just a few weeks of taking this program. And they're now seeing clinical results across a wide variety of patients and continue to post about it to this day. If you're interested, I'd highly recommend checking out Dynalim Technologies online and on LinkedIn, where you can see some of the success and active work that's going on with this TPU rubber-based FDM product. Another example is out of Ukraine. I'm working with a project in Ukraine right now where they took the training on how to make cosmeses covers, and they stood up a whole pipeline around the very template that the course is built on, and we're able to, within 2 weeks, to start designing and 3D printing from scans for these new veterans which are suffering from psychological degradation as a result of losing limbs very quickly. This was going a long way to help with the psychological recovery of those amputees. Again, all based on affordable software and affordable printing on the front line, essentially dodging air raids. So you can do that. You can do this, and there are people who are doing this now. So how does someone like you get into this kind of growth plan? Where do you start? Educate yourself on the tools available from the broader industry of 3D printing. There's a lot of good ones out there, and they cost a lot less. Get an affordable desktop machine and scan with your iPhone. You don't need anything more to start, and you certainly don't need anything more to get to a definitive device. Leverage the existing MJF industry that agnostic vendors use to print for you, so you don't need to buy one of these HP machines to start playing with that material. You will eventually grow into O&P industry-specific software as you make this journey, and you will eventually buy more expensive 3D printers. This is not the end goal, this is the starting point for anyone looking to get their business or clinic into printing today. But the one thing consistent across beginners to mature users is that digital design literacy is the universal language of all of these conversations as you acquire newer and bigger tech. I've been in 3D printing in O&P for over 5 years now, and I have yet to feel the need to outgrow the tools I have been teaching for beginners with my practice and in other clinics. So if you're a beginner, you are facing problems about learning how to design bespoke and custom devices in CAD, learning that lateral creative freedom to do so. Advanced users, as you start to become more and more powerful, move away from bespoke designs and start getting into problems around volume, production, and large staffing coordinations and training at a facility level. And that's at the point when you're ready to look at industry-specific tools like O&P Saas, and you will have the means to define what those custom needs mean to you and to have them fit exactly to your needs, because you are now trained in the literacy of these file types and these design methodologies. So despite all of my harping on being O&P Saas versus process, I work for a SaaS company called Taika 3D. They do design automation for custom insoles, primarily for CFAB facilities and people who are doing high volume throughputs in milling or 3D printing for diabetic inserts or 3/4 length devices, 3D printed devices or otherwise. We create automated CAD design engines that will do 60 to 100 pairs of designs per hour per designer with hands-off design automation, which equates to about less than 1 minute per pair. If you're interested or know someone who has this in their repertoire of issues they deal with on a day-to-day level, come find me after and talk to me. I've got a solution that's very interesting to show you. But again, as a beginner, I think it's more important that we focus on where we start to get to the level where you can now make those decisions for yourself. So it's not just about cost at the end of the day, though. The digital craftsman who chooses his software, who can do the lateral creative movements of creative product development, it's also about why we need you at the front line today. Because I'm not a clinician. I am a designer. I'm an industrial designer. I'm a CAD operator at the end of the day in this ecosystem of clinicians and 3D printing, right? Why we need more clinicians in this space. Large industry and for-profit providers are spending big money right now on training artificial intelligence to facilitate 3D printing and O&P, making up for the historic shortfalls in O&P right now that are holding back the uptake of these tools that have been around for a long time. O&P has been locked out of 3D printing for a longer time than other industries, in my opinion, because the professional base was not proficient in using the modern design tools in fabrication that other industries have been well versed in for a long time. The design step has always been the biggest bottleneck in O&P adoption today, and for both of those looking out to get into 3D printing industry, and for those of us looking in from the O&P, from the broader industry, trying to get into the market, trying to get into creating products that are medically based. You know, that part of it was difficult. I was a part of a 3D printer reseller who did a huge, serious use case for getting into O&P, and it lost out at the end of the day to dental, because dental had so many more check marks done in the design space and in the digital design tool sets that they were used to already using. So large players are training AI models to fulfill the design role, and the design role is the role of the practitioner at its core. This is the part, again, the eye behind the lens, the craftsman who goes in and does their job. You know, the design role is the role of the practitioner. These big companies are not trying to automate this because practitioners are the problem, but they're doing this because that is where there is a lot of resistance right now, both in terms of the learning process and the uptake process. You know, as someone who's actively working in facilitating these issues today, I wanted to also get the message out that it's not just about cost. We need more practitioners at the table for this conversation around future digital care in O&P. We need design advocates, users, and innovators to lead this path. We need clinicians at the table. There's not enough clinician presence right now at the conversations around digital design and automation. Computer programming, insurance, agnostic manufacturing, and a lot of for-profit models right now are defining in a major way how O&P care gets to consumers and patients, and there's less clinical perspective present than there should be. So practice owners, clinicians, and technicians, please, we need to take an active role in defining the future of these tools. Design is not an obstacle to get into 3D printing. It is the crown jewel that gets you there. Digital design and 3D printing is the most important tool chest upgrade this industry has seen probably in the last 50 to 60 years. It's your ticket to the table for defining the future of digital care in this space, and it is the next open market where innovation and entrepreneurship and patient success will come from leading into the future. So I am the founder of O&P Digital Designer. It is an online accredited CEU academy for learning agnostic CAD for O&P applications. You can learn every device type. You can learn several different types of software. You get workflows and templates on how to do everything from parametric design, automations, AFO design, scan preparation, scan cleaning, which technologies to use, which printers to buy. There's a whole route of options that you can choose and take based on what your clinic is offering today, what your skill set level is, or even what software you have existing today inside your pipeline. In the 3 minutes I have left, I can try playing this video here that gives you sort of a preview of what one of these courses might look like. We go through basics on how to use Fusion 360, one of the most prevalent and popular products today in software in O&P. You're going to learn how to do things like manage and navigate assemblies. You're going to learn how to do 3D source manufacturing from online vendors who will do your MJF printing for you. You're going to be able to create socket designs and clinically modified trim lines and offloads. You're going to be able to then innovate and create your own solutions and recycle these parts. You'll have a parts library by the end of this training. You're going to have templates by the end of this training that can be used immediately in patient projects to get anything like the hole patterns on a pyramid adapter or the actual diameter of a shuttle lock. You know, all of these things were reverse engineered using standard technical techniques that I've learned throughout the industry. These will give you assets that are going to immediately recycle into your patient care, allowing you to reduce the cycle time it takes to get designs out. When you make a template, it's going to take you 8 hours. By the time you start using it and repeating it, it's going to refresh in 10 minutes. And that's the power of the digital design automation pipeline that these softwares try to train. They give you the tools to be able to do this all under your own power. You're going to own the IP. You're going to own the workflows, and you're going to be able to innovate and create your own products. And that's the most important thing for clinicians today. How do you retain ownership of the design step and become an active member of this process? So these are the companies today that have been a part of my academy training. There's 160 graduates right now worldwide across 6 continents, over at least 50 different medical institutions, ranging from hospital care to small single practices in the middle of the Australian outback. There's a lot of examples online for outputs that have been made by the graduates of this program, where they share exciting new innovations, things they're trying, products that have made it to the patient, and their feedback on what it looks like. You can find and leverage a stronger community of questions and comments and ideas for you to try yourself. There's, again, this process-specific software has a community, and it's growing every day. So, in conclusion, craftsmen invest in their skills instead of buying machines. You invest in tools that everyone has access to, and you build a community around it. You build the relationships around it. You leverage technology that provides better outcomes for your patients, because it is about your patients. If you're not focusing on making a better product, how are you going to stay valuable to those patients over time? Adopt the craftsman mindset, because it's going to be really easy for you to make those right choices to complement your existing tool chest. So, thank you for your time. My name is Arthur Hobden again. If you would like to come talk to me or have any questions about agnostic CAD or software workflows for your small to medium-sized clinic, come talk to me. I'm a wealth of information and love to share. So thank you very much.